What's up, math fans? Welcome to Sweater Fridays and welcome to a follow-up video on circles. Again, there's a lot of stuff to do with circles, but this one follows the first circle video, which talked about central angles. Central angles is an angle that has a vertex in the center of a circle, and you should know, hopefully if you saw the video, that the measure of a central angle is equal to the measure of the intercepted arc. And I was saying it's all about pizza slices. Now we're going to make slimmer pizza slices because these angles don't come from the center. These angles come from a vertex that is on the circumference of the circle or on the circle. All right. So here, this is not a central angle. The vertex is on the circle. That's an inscribed angle. And an inscribed angle is related to a central angle, but it's not the same. It's like its cousin. All right. So I'm going to do a quick. It's not really a proof. The proof is a little bit longer, so it's just a quick demonstration of relationships between central angles, inscribed angles, and the intercepted arc. So here's a circle. Here's the center of the circle. I'm going to draw a central angle to remind you. Remember, this central angle is equal in measure to the intercepted arc. Let's say this is A, B, O. Okay, so whatever this is, that intercepted arc is the same. I don't know, let's say it's 80. So let's say this is 80, means the arc is also 80. Now, I'm going to draw an angle that has the vertex on the circle itself. I'll call it V for vertex. AVB, just by looking at it, you should see, is smaller than AOB. And how much smaller is it? It's exactly half. So this would therefore be 40 degrees. Okay, the inscribed angle is 1/2 the measure of the intercepted arc. So this pizza slice has a little bit of a slimmer corner. This pizza slice is half of the intercepted arc. If the crust is 80, the angle is 40. And notice 80-80, 80-40, okay? So there is a relationship, you just gotta follow those pizza slices. All right? Another demonstration would be just draw a circle and an inscribed triangle. So something like this. Here, all the vertices, A, B, C, are all on the triangle. Now think about this. What is the sum of the measures of angle A plus angle B plus angle C? Don't those three angles add up to 180? A plus B plus C equals 180. But what is the measure of an entire circle outside arc AB plus arc BC plus arc AC? Those three, AB plus BC plus AC, add up to 360. So if you look outside, that's 360, but inside is 180, that's half. So the inscribed angles are half of the intercepted arcs. That's another way to remember it. All right, once you remember it, you're good. You don't really need the proof. So we can start answering questions. Look at number 1. What are we going to ask here? What is the measure of angle B? Well, the inscribed angle is here, and the arc, or the intercepted arc, is 100. So if you're not sure, you just follow that angle out. Oh, look at that. There's my pizza slice. And this is 100. Get your calculator. 100 divided by 2 is 50. Keep in mind it works both ways, meaning they might just say, hey, look, that angle's 50. What's the arc? What's the intercepted arc? You should know to go the other way, multiply by 2. So it's not always half. It depends which direction you're going. If I start with the angle, a lot of people say, oh, I remember half. It's half, right? So 25. No. It depends which way you're going. So if the angle is 50, the arc is 2 times 50, which is 100 degrees, okay? Depends which way you're going. Ready? Number 2. Oh no, now it gets crazy. It doesn't get crazy. Follow the pizza slices. Don't worry about what they put inside. It's geometry class. Of course, you're gonna start to put shapes. Here's a pizza slice. You gave me 110 degrees. I'm gonna follow this thing out here, and I got this big old pizza slice. If this inscribed angle is 110, the arc, intercepted arc, is double that. 2 times 110 is 220. So out here is 220. Now be careful. So from A all the way to B is 220. we're ignoring C for a second. A all the way to B is 220. So let's say they gave you this before I found the 220 and they said solve for X. I would get confused, I would get flustered, so you go step by step. I know this, now I know that. What else do I know? Oh, I got this whole arc, that's 220. Ooh, I got this other piece, that's 50. And I got the final piece of the triple arcs, which is 30x. And I know when I add them all up, I get a full circle. Measure full circle, you gotta know 360 degrees. So let me combine like terms here. What is this? 270 plus 30x equals 360. Oh, I'm gonna subtract 270 from both sides. 30x drops down equals, what is this now? 90. So if I divide by 30 on both sides, hopefully you can still hear me, x is equal to 3. X is equal to 3. And that would be your answer to number 2. And then you can do whatever you want with it. If you have to plug it back in just to check your work, 3 times 30 is 90. 90 plus 50 plus 220, hopefully, is 360. Let's go to number 3. What's given? What do they want? Solve for x. Here's a cool trick that I might have showed you in the last video. You don't know anything about x, do you? You don't see any numbers at all. Oh, I give up. I don't want to do algebra. Do algebra. You know you're going to have to set up an equation eventually. It's not always going to be as simple as, oh, just double it. So, what do you know? I see a diameter. Diameter cuts the circle in half. That side is going to be 180. This side is going to be 180. So I just add this plus this to get 180. So, make the equation. We got 7x minus 10 plus 13x minus 10 again equals that half of the circle, the semicircle, which is 180 degrees. This is going to give me 20x minus 10 gives me minus 20 equals 180. Add 20 to both sides. 20x equals 200. Divide by 20, divide by 20. Another easy division question, and x equals 10. 10. Now, how does that relate to inscribed angles? Well, then they might ask you, well, find all the inscribed angles. So you would now know that if x is 10, this is 7 times 10 is 70, minus 10 is 60. This arc is 60. Follow the pizza slice. If this is 60, this angle right here is 30. Look at this angle right here. Can you guess what it is? It's opposite a diameter. It's opposite a semicircle. It's a right angle. It's 90, 180, 90, 180, 90. And I'll let you figure out that last piece. And I'll let you figure out this third angle on your own. Thanks for watching Inscribed Angles. See ya.